All right, here we go. Now we're going to talk about dependent equations, right? So now dependent equations, remember again, going back to our discussions before with systems of equations, right? Dependent systems are representing basically the same line or the same plane, right? It's basically a line on top of a line or a plane on top of a plane, right? So again, when we're dealing with matrices, same thing. We're looking for dependency, right? So what happens when we're dealing with something that has dependent equations? Okay, so let's use this example, right? So the first thing we're going to do is put this in standard form, right? So we're going to put this. Now, one thing I'm going to do is get rid of these decimals by multiplying everything by 100, right? So that's the first thing. So I'm going to multiply this top equation by 100, so that's going to give me 25x minus 75y is equal to 1. Okay. Right. Okay, so now we have so here we have this equation here. So let's move everything over to the left. So I'm going to subtract x from both sides, right? So that's going to give me negative x plus 3y, right? I want the x's and y's lined up, and that's going to equal negative 4. Okay? So now that we have it in this form, now I'm going to put it as a matrix. By the way, notice that never mind. So let's do this. So I'm going to put it in matrix form. So this is going to be 25, negative 75, and 1. And then we have negative 1, 3, and negative 4. Okay? Now, I'm going to interchange these two. And let's do that. I'm going to interchange these two. So I'm going to swap row 1 and row 2. So row 1 swap with row 2. So this is going to be negative 1, 3, negative 4, 25, negative 75, and 1. Okay? Then I'm going to multiply the row 1 by negative 1. So I'm going to take negative row 1 and then replace row 1. So basically, again, I'm just multiplying the first row by negative 1. And so that's going to give me 1, negative 3, 4. And then the second row is unchanged. That's 25, negative 75, and 1. Now, if I multiply the top row by 25, negative 25 rather, I want to multiply the top row by negative 25. So negative 25 times row 1 plus row 2, and I'm going to replace row 2 because I want to get rid of this 25, right? So I want to make that 0. So now if I do that, I get, again, the first row is going to be unchanged. So what do I get? I get negative 25 plus 25, which is going to give me a 0. And then negative 3 times 25, negative 3 times negative 25 is going to give me 75. But 75 plus negative 75 is 0, so that's going to give me 0. And then 20 times 25 times 4, oh, I'm sorry, this is supposed to be 100. Oops, yeah, I forgot to multiply this by 100. This should be 100. My bad. Yeah, I forgot to multiply that by 100. So yeah, okay, so this should be 100, and then this should be 100, and this should be 100. Sorry about that. Let me turn this off. Okay. Okay, so now this is right. And then if I take negative 25 times 4, I get negative 100 plus 100, which is going to give me 0. And so now I get this row of zeros here. Okay. Now this here, again, remember from last video, I mentioned this, that this means something else. Well, now you know what this means. So if you get a row of zeros, this is always true, right? So what this means is it's saying 0 is equal to 0, which is always true. It's a true statement. So that means that these two lines are representing the same line. These two equations represent the same line. Okay? Or in other words, you can see that one line is just a multiple of the other line. So whenever you get a row of zeros, that's what that's telling you. So these represent parallel lines. If there were three equations with three unknowns and you got a row of zeros, then that would tell you that the planes, all three planes are parallel. So you have parallel planes. Okay? So that's what that means. All right. Have a great day.